Hi guys, welcome to another day of notes. Today we're going to do day 3 where we're going to talk about multiplying, special cases, and factoring out a GCF, which is greatest common factor. So there's two kinds of special cases for multiplying, which is a square binomial, which basically is you're multiplying the binomial by itself. It can look like this, either some number plus another number squared or some number minus another number squared. If it's plus, it's special because, well, you write it out this way, sorry. It's special because it will always look like this kind of setup. Once you simplify it, it'll look like that. With subtraction, you can either spread it out and that way you can multiply it like normal, or it'll always look like this kind of setup. The product of a sum or difference of a binomial, which is basically you're multiplying the same binomial, but the only difference is one has an addition sign, one has a subtraction sign. It's special because the middle terms will cancel out when you multiply. So it looks like this, and when you multiply together, what you'll get is the square of the first term minus the square of the second term. Okay, so let's look at a couple examples. So example 1, we have 3n plus 2 squared. So if you use this setup, 3n would be your a and your b would be 2. You could fill this in then. So you have 3n squared plus 2 times 3n times 2 plus 2 squared. And you'll get your answer of 9n squared plus 12n plus 4. That only works if you go ahead and memorize this. I'm not a fan of memorizing. So I go ahead and just multiply it out. So I spread it out, then do multiplication either with box method, double distributing, FOIL, whatever you got to do. You'll end up getting these 4 terms. And then what happens is they actually simplify to be the same answer. Okay? So if we do the same thing here, you could fill this in. Your a is 2g, your b is 1. Go ahead and fill it in. And then you just simplify. You get 4g squared minus 4g plus 1. Again, not my biggest fan because you'd have to have it memorized. So I actually just expanded out to be 2g minus 1 times 2g minus 1 and use my preferred method of multiplying. So I would get the 4 terms of 4g squared minus 2g minus 2 plus 1, and it would simplify to be the same thing. So now you guys are going to try these two on your own, and we're going to move on to example 2. So this is the sum and difference one because they are the same numbers but different signs. So I can go ahead and use this setup where I know what a and b are, and I can just write it as a squared minus b squared. So here a is 4r, so I would go ahead and square that, and b would be 1, so I would square that and just simplify. I get 25r squared minus 1. Or I can go ahead and multiply using whatever method I want. I would end up getting these 5 terms, and I would combine the r's together, but when you combine positive 5r and minus 5r, they cancel out, so you're still left with the 25r squared minus 1. So that's why the shortcut kind of works. This one's not as lengthy to memorize either, so I kind of like it. So now you guys are going to try this one on your own. Okay? So that was multiplying. Now we're going to talk about factoring out a GCF. So factoring out basically is undoing distributive property. Okay? So GCF is the greatest common factor, which is the largest positive integer everything can be divided by. So when we're factoring out a GCF from a polynomial, we're basically trying to figure out what numbers got multiplied to create that polynomial. Or not numbers, but like which polynomials got multiplied together to create it. So let's start with just numbers because that's a little bit easier. We're going to find the GCF of 28 and 42. So the first thing we're going to do is write out all the factors of 28. And those are the numbers that multiply together to create 28. So, sorry, it's a little loud. I'm in the hallway right now. We got 1 times 28, 2 times 14, 4 times 7. Okay? We do the same thing for 42. 1 times 42 will work, 2 times 21 will work, 3 times 14 will work, and 6 times 7 will work. So if you look at all the numbers, the biggest number they have in common is 14, and that's our GCF. Okay? If I was doing with variables, I can't just write down a bunch of different variables because it's basically made up of the same thing. So what I do is I write it in expanded form. Okay, so I have x to the third is really 3x's, x to the seventh is 7x's. And now I'm going to look how many x's they have in common. So this guy only has 3, but this guy also has at least 3. So that's how many x's they have in common are 3. And I would just write it in exponent form for my GCF. So the biggest GCF they have in common is x to the third. Okay, so now you guys are going to try these two on your own. B is a combo of both, so you're going to go ahead and try that. Okay, you got to do both parts, the numbers and the variable, and then combine them to create your GCF. Okay, now for the polynomial part. So with polynomials, you're basically trying to figure out what two things got multiplied together to create this. You're undoing distributive properties. So we use GCF to figure out what to undistribute. Okay, so if we look at these two terms, the only thing they have in common are numbers. They both have numbers. So that's the kind of thing we're going to find our GCF of just numbers. So I write out my factors for 3 and 9. I've got 1 and 3 for 3 and 1, 9, and 3 for 9. The highest number they have in common is 3, so that's my GCF. But I'm not done. They didn't ask me what was the GCF. They asked me to factor it. So what I have to do now is take this out of the polynomial and write what's left over next to it. So if I divide each of these terms by 3, the leftovers is going to be the second half of this problem. So divide each term by 3. 3 squared divided by 3 leaves me with x squared. Negative 9 divided by 3 leaves me with negative 3. So this is what got multiplied together to create this problem. And this will be my final answer. B, it's a little bit more complicated because it's variables and numbers. So I do it for both. So each term has numbers. So I found them, the factors for each one, and just wrote about. And the highest one they actually had in common was just 2. So that's part of my GCF. But now I have to look at the variables. If I look at my variables, I just write them in expanded form. So I have 4 here, 3 here, and 2 here. The most they have in common is 2 variables. So I got 2 and x squared as my GCF. So now that's what I'm going to divide each term by to get my leftovers. So 6 divided by 2 leaves me with 3. X to the fourth divided by x squared. I'm just going to subtract the exponents. Leaves me with x squared. Okay. 18 divided by 2 leaves me with 9. X to the third divided by x squared. I subtract the exponents. I'm left with an x. Negative 16 divided by 2 is negative 8. X squared divided by x squared. The x's cancel out. They're gone. And I'm left with negative 8. So that's my leftovers. And the whole thing, like both of these things set up so they're ready to be multiplied together is my final answer. Okay? So if you have any questions, please write them down. I will answer them next class. These two are your try on your own, so I will see you guys later. Bye!